Okay, everybody, ready to get started with this week's forum. Today we're going to learn about the lost history of sulfide ore in Wisconsin, right?
That's right.
Rob Lodge from Geology.
Thank you. All right, everyone, thanks for coming. A lot of familiar faces in the audience today. Thanks for coming out, Geology. So today is really a story of what we've learned in the past 5 years of researching Wisconsin's ore bodies. And I'll begin to approach, I guess, future directions in this research, and then what do we actually want to know about Wisconsin's resources. For those of you that aren't familiar with this image, this is our only producing copper ore body in Wisconsin. This is the Flambeau mine site. The town of Ladysmith is just up this highway. And this operated for 3.5 years and then shut down in 97, completely reclaimed by 2000, and now it's just a path, a walking trail, and there's a horse track and things like that there. So it's a completely different landscape than in this image. First of all, I got to acknowledge a few people that funded this research. First and foremost is ORSP. I didn't have a dime if it wasn't for ORSP to conduct this. But then as momentum picked up, we started getting people interested from the outside. We got sponsorship through the Wisconsin Geologic and Natural History Survey and the USGS. And also my former PhD institution, Laurentian, chipped in a few bucks here to pay for some chemistry, so I have to acknowledge them as well. So if you happen to go onto Google and just type Wisconsin sulfide mining, you get a range of news articles pop up now. And it's a little different now, but if you did this last year when they were going through some legislation changes in the state, it was quite an entertaining suite of news. And so, you know, they're paying homage now to the Brazilian tailings dam break and saying, is Wisconsin next? And then, so you're getting a lot of environmental concern with sulfide resources in Wisconsin, and rightfully so. You also get, you know, people at the county level now making law changes. Marathon County is sort of taking the lead on this. Then you get down a little bit further, and now we see the actual timeline and when we actually changed Wisconsin's mining legislation. And so it's become a renewed conversation. And part of the reason being is because when we picture mining, a lot of people picture something like this. Some decrepit, rusty junk hole with old buildings and strange colored ponds and dead trees and unprotected slopes, and you know, in fairness, you know, back in the 60s, 70s, this is what mining looked like, and so it is in that regard a fair image. But why it's still part of our conversations is because, well, we use this stuff. If it wasn't for mines, we wouldn't have the stuff we use and need. And I use the word need loosely, but I mean, if I had to go around the room and take away your cell phones right now, I think you'd understand what I mean by needing. And so, you know, the circuits in our cell phones and computers are actually gold. You know, Lady Liberty is made of copper. Our brass fittings and plumbing and electricity through this building is copper. Our batteries in our vehicles are mostly lead. Then you want to go to the green side of things. Solar panels. A lot of the circuitry here is actually silver as far as, you know, making solar energy. And me with 4 kids at 5 and under, diaper cream is actually a pretty important part of my life. And so, you know, zinc is actually used in a lot of ointments and medications. And so, you know, and all these things, and I could have put up more images of this, are derived from the metals that we extract from ore bodies like we have in Wisconsin. So we think this with mining, but then we don't realize how much of our stuff comes from these resources. And so this is why it's still controversial. So this image, as a geologist, I look at this image and I think, wow, this is pretty cool and spectacular, and these beautiful crystals. This is what a sulfide mineral actually is. And speaking to a room of mostly geologists, it's kind of fun to do this. But you know, this is pyrite, this is an iron sulfide, and this mineral, as beautiful it is to a geologist's eyes, is a big part of the problem as far as mining goes, because this is a major component of our sulfide ore bodies here in Wisconsin, but it's also the biggest waste in terms of this is what we don't use. And so this is what gets discarded, and then problems fall out from that. So again, speaking to a more broad audience than what I have in the room, minerals are the naturally occurring crystalline solids that make up our rocks. And sulfide minerals in particular are minerals that are bonded with sulfur. And so we have things like pyrite and pyrrhotite, which are iron sulfide minerals. We have sphalerite up here, which is our zinc sulfide mineral. We have chalcopyrite, which is this gold color one through here that is an iron and copper sulfide. Our state mineral galena is a lead sulfide, and we also have nickel sulfides that occur in this region as well. So there's a lot. You look, you know, the zinc, copper, lead, nickel. These are all very important metals to our day-to-day life. They're commonly pretty dark in color, very metallic, they shine, and they're often very heavy as far as if you ever had to hold them. If you want, for those of you that aren't geologists, if you want to come over to Phillips Hall, I got a whole whack of these things if you wanted to just feel them and touch them and learn a little bit more about them. And so as far as their abundance in our natural environment, all right, it could be as obscure as a trace amount of sulfide, a little pyrite green in a sandstone, when that oxidizes and creates some of the rusty colors that we see in our sandstones. It can be a little bit more abundant, all right? You can have little veins and pockets of these sulfide minerals, and these are naturally occurring. If you've ever been north of Highway 8 driving along, you see these road cuts and there's little pockets of rust on them. Those are naturally occurring sulfide minerals. And then all the way up the spectrum, we can have basically rocks composed of completely sulfide minerals. And this particular mineral, this particular rock, this is a core sample, we have these gold colored things here, that's chalcopyrite, the copper sulfide mineral, and this black stuff in the middle here, that is zinc sulfide or sphalerite. So it's these rocks that make up the ores that are in Wisconsin. And so how do we actually form these things? I got a small YouTube video. I'll kind of speak through it, so don't mind the sound too much. Oh yeah, I got to go display, duplicate. There we go. These sulfides, these massive sulfide things, are actually currently forming all over our modern ocean. As far as ore forming systems go, it is one of the few that we can actually see it actively happening. Is there a geologist's reaction to these kind of things?
There it is. Iconic structure of oceanography.
And geology.
Looks like a little beehive up there.
So if you look at this thing, you can actually see this sort of churning black smoke coming out of this thing. This is actually superheated seawater, about 300 to 400 degrees, and that black soot coming out of it is actually basically sulfide mud. And so this thing will accumulate at the seafloor, in this chimney, and below, and that is a massive sulfide deposit forming right now on the ocean floor. It's also got all kinds of critters. Bacteria cultures are eating these sulfides. These things are eating the bacteria. You got a diverse food chain that's living completely in darkness, completely surviving on this sort of unique ecosystem. So as far as, and I'm going to stop the video now, you got the idea of what a black smoker is. as far as discoveries in geology, this is actually a relatively young one. We didn't have the technology to go down 4 kilometers under the ocean and look at this stuff until relatively recent. So this is, you know, understanding these ancient things that we have here really got new life by discovering things like this on the modern seafloor. Oh, let's get going here. So, I showed you these black smokers on the seafloor. Why do we have this stuff in Wisconsin? Last time I checked is that we weren't 4 kilometers under the ocean here. Okay, so meet Wisconsin's 1.8 billion year old volcanoes. So this is northern Wisconsin, just for sort of some frame of reference. Flambeau is just outside the town of Ladysmith. All right, this is Rhinelander right about here, and this is the town of Crandon. So Highway 8 kind of zips right through all this old volcano. And all these red dots represent our potential ore bodies, and what we know of anyway right now in Wisconsin. So you can imagine that every one of these little red dots represents this funny little thing that is now currently in our bedrock here in Wisconsin. So all the green colors we're seeing in here, these are all basically ancient lavas that made it to surface. All these pink blobs through here are all like feeders to that system. These are like old, basically intrusive magma bodies, and these are the volcanic rocks sitting on an ancient seafloor, and these are all the black smokers in these red dots. So 1.8 billion years ago, Wisconsin was a little different. So just to highlight some of the things that we have here, we got the proposed Crandon mine in Forest County, Wisconsin. It's 67 million tons of ore. And just perspective, that's a lot. All right, this would be a world-class deposit scale of ore body. You can see that it's zinc and copper. It also has significant gold and silver. It's the largest one we know of in the state. It tried to go through permitting in the 80s through 90s. Eventually, it got shut down because of legislative difficulties and environmental concerns. So right now, this is not actually a thing. It's also, there's reasons why this might not ever be a thing that I don't have to talk about in this particular lecture. All right, we have one that is close. This is Wisconsin's other ore body. It's actually technically in Michigan. All right, there's the Menominee River. So this is Wisconsin, and that's Michigan. And this, because it's in Michigan, is the only reason why this is actually progressing towards. It's actually just about 1 permit away from being able to put a shovel in the ground. It's a fairly big one as well, 18.8 million tons. It's got a lot of silver and a lot of gold in it. And it was actually relatively young in terms of discovery. We only discovered it in the year 2000. And like I said, it's almost near permitting. Then we got Wisconsin's only producing mine, or past producing mine, is the Flambeau mine in Rusk County. It's only about an hour-and-a-half drive away in terms of seeing it. So this is the only, it operated from 93 to 97. I use the analogy of giving one of my kids a cupcake with icing on it. And so my kids will take that and they'll lick the icing off and they'll just throw away the cupcake. I don't let them do that, by the way, but I'm saying hypothetically they could do that. And so you can think about now using that analogy for an ore body. This part they actually mined was enriched. Basically, certain processes go into creating a more enriched ore body, so it had extra sugar in it, extra metals. Still beneath this is about 5 million tons of massive sulfide ore that wasn't enriched, right? So that's the rest of the cupcake. Still delicious, but they never, so just they licked the icing off and they went away. They left the cupcake in the ground. That's something that not a lot of people realize about the Flambeau ore body, is that they mined just a small portion of it. So, what does this mean? What does it might have looked like back 1.8 billion years ago here in Wisconsin? This is something, we don't actually have a great analogy for it right now in terms of modern tectonics and things like that. But it might look something like the southwestern Pacific if we were suddenly colliding into Australia. All right, if we can imagine that sort of scenario Geologists might be able to in the room. All right, we got this scenario here where we have, this is a subduction zone, this is a volcanic arc right here, but in behind this thing is a whole lot of exhalative black smokers and almost littering this entire area. So if you can imagine now just basically smashing that into a continent and pushing it up on land, that is how we preserve these things in the modern, or so we take these ancient environments and preserve them on the continent. We have to basically push them up there somehow. We do that by mountain building. Now, getting into the research side of things, let's look at Flambeau's timeline, which is actually pretty representative of a lot of the mineral properties here in Wisconsin. So first, the mining history. All right, they discovered Flambeau was one of the first in '69. They mined it until 97, 93 to 97. They reclaimed it in 99. All right, technically this should be over this side of the line. But this red line here is an important turning point as far as understanding the geology of Wisconsin's ore bodies. This is when they put into place Wisconsin's Prove It First mining law, the sulfide mining moratorium. And this is legislation that basically said you have to prove it first before you can mine anything. So you had to take a mine that was operating for 10 years and show it hasn't polluted the environment, which at this time, not so bad. But this is the ingenious part of this law, is that you had to show a mine that was closed for 10 years and not polluted. And now you're pushing it back into the 80s, and now we're going back into images like I showed you at the beginning of this, right? So it took a long time for not only to have a mine shut down under modern environmental standards, but then to have public perception, or at least political perception, turn enough to actually change the laws that I showed you at the beginning. Okay, so that's the mining history. In terms of understanding just geology in Wisconsin in general, especially the old stuff up north, all right, there wasn't a lot. We had a couple of papers in late 80s, early 90s. We had the Institute of Lake Superior Geology Guidebook published in '96, knowing when this thing was coming down the chute. And otherwise, we had a couple of very broad papers published relatively recently. And again, that's it. I was actually stunned to find out how little there was on Wisconsin's north. Now, going to deposit scale, this is where the reason why a lot of this is absent. All right, so we had a paper published to talk about Flambeau's discovery, the ILSG guidebook in '96. There was one thesis in '97, and that's it. And part of the reason being here is because once the companies left town, right, there was no more drilling, and there was no more money for research. You know, there was no private investment in research and understanding these things more. So that's it. It just dropped off. And it wasn't until I got here in 14, managed to get my feet underneath me enough to get started research in 15 through, I guess, today, is when UW Eau Claire students have stepped in this picture and began to rediscover these deposits. So why is this such a big deal? First of all, you just can't go out there and look at the stuff. The geology in Wisconsin is covered by glacial deposits from the last ice age. And so, I mean, you got, in places, hundreds of feet of glacial deposits covering the bedrock. So nothing's exposed for you to go look at. And the geology was only described through drill core. And so through the mineral exploration process of looking for these ore bodies, that's how we discovered this geology. And perhaps now going into legacy, Wisconsin state laws don't require exploration companies to submit their materials. I'm from Canada. I spent a lot of time in the mineral exploration industry there, and provincial laws there require you to submit drill core and records of your exploration to the government, and then they'll eventually release them to the public. In Minnesota, it's the same thing. They're required to donate their core and their records, and then it's, you know, released. Here in Wisconsin, completely voluntary submission. So anything that was submitted is just completely scattered and in pretty poor shape. So didn't have to submit it. last time they explored was in the 1990s. A lot of the geologists there, the senior geologists who knew the most, are now retired or worse. Okay? Companies are gone, so there's no funding anymore. And any surviving records are all hard copy, faded maps, or basically typed documents, and they're very poorly archived, if at all archived. For a little story, I called Rio Tinto up, who is now the owner of Flambeau property, just through big companies eating little companies. And they said, it's in a warehouse somewhere in a box. We'll call you. Okay. And then to make it even more, all right, so you don't have to submit it. Everyone's retired now. But because of the nature of exploration and this sort of not requiring submitting records, exploration was very, very competitive. And so people were holding their cards close to their chest, and no one wanted to share. So even just later on donating materials, they're like, no, I might do this one day. And so this, people are taking this to their grave. So some people, no one wanted to share at the time, and some still don't. So that is, it's one of the things I discovered coming down here. All right, so that's the background story here. What have we learned about Wisconsin's mineral resources? What have UW-Eau Claire students done since I've been here? So the research goals coming in this, pretty broad. I wanted to learn everything because there was nothing. So there was no direction I couldn't go that that my students and I wouldn't have valuable contributions to. So figure out what's still there, all right? So look for drill cores, sample suites, reports, try to find even more, so what I can get publicly, make some friends, maybe someone will want to, collaborate, and then take all this stuff from the 90s and earlier, and then use the past 30 years of advances in my field to then push this knowledge even further, to rediscover these resources in a modern pre-Cambrian and economic geology context. So that was my goal here. So I had field-based studies, students logging countless linear feet of core. I'm looking at one of my research students here now, like the amount of core that we've logged there is crazy. Dragging them out on rivers to actually see the little bit of outcrop that we do have, taking samples back to Eau Claire. And the purpose of these field-based studies was really to sort of paint a new picture of the geology hosting these deposits. So here is an example of one of the maps we produced. So this is Rusk County. We went out and I sent students out looking for outcrop. We spent an entire summer. We found 23 in an entire county, just for record. And so just trying to understand the bigger picture around these volcanoes, trying to put these black smokers into context. All right, we had compilation projects where we had just literally a beer box of reports and rocks and a tube of old maps. And so we took this and we digitized these old pieces of junk that you could barely read, put colors on them. So this is the final product here. We took samples and did portable XRF analysis, trying to just take anything, scrounging up all the information we can. In fact, we got so far, we managed to put so many of these and we made a 3D model of the Cranon deposit just from old scan maps. So we can reconstruct drill hole paths so then we can understand where these samples are coming from within that stratigraphy. So this is the level that we've gone to sort of rediscover these deposits. So we've done geochemistry-based projects as well. So this is just now understanding the chemistry of rocks. There's an existing tectonic model of how northern Wisconsin got here. So there's the map of northern Wisconsin, and they thought it looked something like this, where we had some volcanic thing. This is the rest of North America, and then it smashed into there, and that's when we got our VMS deposits form, and then this smashed in, and that's where we are today. It's completely overblown and simplified, but that's the story, all right? And so what I wanted to do with my students is now take a step back and really begin to test this, because again, a lot of the data this was built upon was old data and secretive data. So and a lot of it was just based on ages and not really a lot of sort of looking more at the individual volcanic centers and putting them into context. So that's what we did. All right, so if you didn't know this, now you're about to. All right, so I got a bucket of rocks here. It actually contains all the stuff on the periodic table. Well, not all of it, but a good, there's a lot of elements in an individual rock. Turns out, though, there's a handful of these that actually are very sensitive to tectonic and volcanic setting. So depending on where you are in terms of a tectonic picture, it'll have unique characteristics of these elements, unique abundances of these elements. So we can kind of go to this old bucket of rocks, look carefully at these elemental abundances, make a few comparisons, and come up with a good idea of where these rocks formed in terms of a modern tectonic setting. And that's what we did. We started looking at just the Flambeau volcano and how it formed. We looked at the Eisenbree and how it formed. We looked at the county-wide stuff and how it formed. And I'm not going to go into a lot of these diagrams, but I'll give you the theme of it, all right? A lot of these, you look at these elements, these are the elements that I talked about. And depending on ratios and different abundances, we can tell whether something was a continental arc versus a volcanic arc. We can tell whether we have mantle-derived melts or we have some sort of degree of subduction zone going on. We can tell what type of felsic rock and where they formed. And so we can use these to help discriminate the tectonic and magmatic setting of these things. Then we got into deposit scale research. So now we're now looking at the bigger picture stuff. We're looking at the actual deposit itself. And we've done two different things. We look at just the way that the rocks are altering. When you got this black smoker and all these fluids rushing through it, the rock that those fluids are rushing through gets kind of messed up. In fact, that's where all the metals come from. So they're getting very hydrothermally altered and getting all kinds of fun, strange minerals in them. And so we've taken these things and looked at how these types of alteration and elements move around throughout the drill hole. We've looked at basically balancing chemical gains and losses and discovering different alteration trends there. We've got students looking at thin sections of rocks. We also got students looking at the ore zones themselves, the actual massive sulfides, taking thin sections, looking at them under a microscope or a scanning electron microscope. Because a lot of these little bright dots in here are unique, very sensitive elements and metal and minerals that only form under very restrictive conditions. So we can begin to build up fluid histories in terms of temperatures and redox ability, conditions and so on, all right? So this is the level of things that we've been looking at. And here is the different map showing the outline of Wisconsin, but here's all the black dots. So far our students have gone looking at 5 different deposits, and we've got a few publications to show for our efforts, all right? So this is the student-authored external presentations. This is not Circa, this is just outward in the world, presenting our stuff to professionals. See, there's Bruno right here. So we've been very successful in this research, and I could also say it's kind of very lonely at the same time because there's no one else out there presenting Wisconsin sulfides. So we go to these conferences, and it's our students running the show. So to summarize the things that we've discovered in Wisconsin, first of all, retired exploration geologists are not all friendly. Some are very, very critical and very intimidating, despite some of them not being all that tall. That's anyway. And some of them were just, like I said before, they're going to take this stuff to their grave. They don't want to share. There was one story where I was speaking to one of these retired geologists, and they had a younger student kind of working with them within their new consulting company. And I remember this younger student said, "Don't you have, about to talk about a certain map?" And he kind of he hushed her. He's like, "No." So wow, really, this is not a very collaborative environment out there for Wisconsin. It's not what I expected for the upper Midwest. But, But more on the geology side, I think after looking at all these individual volcanic centers, we're discovering that the ore-forming tectonic system might not be as straightforward as we originally thought. It might not just be one arc smashing into it and developing a back arc system, which we have all our black smokers in. It works for some. But for example, the Eisenberg deposit I had some students work on, that I currently have some students working on, is really, so far the data suggesting that it's not deposited with these other ones. In fact, it might have been formed here and then brought into its current place, and then everything else kind of formed on top of it. So we have what a geologist would call lochness VMS systems in the Pinokian, which is kind of neat. We're also discovering that a lot of the metal differences, if you look at sort of how much copper, zinc, lead, and gold and stuff is in these different ore bodies across the state, is that there's a very systematic difference if you look at a map scale, but the differences are coming down to almost exclusively purely fluid dominated, not volcanic dominated systems. So for example, we're finding that the Flambeau VMS system is a much more acidic, and I mean more acidic. These black smokers are quite acidic on their own, but it's different than your average black smoker, which might be contributing to its gold grades and its unique alteration that's not present in the others. So, lastly, what do we need to know about Wisconsin sulfide resources? And this is a question as a geologist, as an economic geologist. What I need to know is very different than what a lot of other people might need to know. And so I really turn this around as a perspective thing. And so what do you need to know about Wisconsin sulfide resources really depends on where you are in the story. And so from a general perspective, from a general public perspective, and I gave a talk at Wisconsin Counties Associations and Town Associations, and the questions there that I got at this particular thing was very different than the questions I get in a room like this. So there's a difference, right? So first of all, people want to know what's in the ground. Just quite simply, what's there. And then there's a lot of slanting on the story, all right? So they really want to know, like, who's telling the truth? Is it people saying sulfide mines are okay, or is it people saying sulfide mines are monsters? They just want to know the truth, and they don't know where to go. And really, that slant on the sulfide story is something that we're always going to be victim to. There's always going to be groups advocating for one side or the other side, and to get the truth is near impossible from a general public perspective. And then once they get the truth, all right, then they got to decide, what are my core values as me as an individual? What do I cherish most? To be, what sparks joy in my life, and how does these things potentially impact that? So let's just say perhaps you are an individual that first and foremost your natural environment needs to be protected and preserved. And therefore any sort of development that will create a scar on the landscape is not okay. And if that is your perspective, then that is okay. Now, if you are from a perspective that you are struggling in your remote community and you're just looking for jobs in any way they can come to your town, and you're not willing to move, maybe it's personal, maybe it's financial, but for whatever reason you're not leaving town, then the prospect of a mine coming in and generating good paying jobs is something that you might be in favor for at all costs for your own. So again, this is really, what are your values and how does this impact it, is really the question that the general public has to search for within themselves. From a mineral resource perspective, again, all the geologists are retired now, and they're all holding their cards close to their chest. So any new companies coming in are asking the same questions. What's in the ground? How do we find it? And so where can I get the geologic information that will help me decide whether Wisconsin's worth investing in or not? which has its own fallouts. But again, like, you know, I came into situations and I'm just going to call it the survey. And the survey's like, I don't know, because no one's been here in a while. We got this core library full of stuff, but we don't really understand what's there. So, you know, it's been a journey. And so I'm coming into this perspective. Any company coming in is going to have the same perspective. And then, can I use this existing data to help me find new ore bodies? And I think really this is where our students are coming in to this equation. From a political standpoint, again, what's in the ground? You know, I was at this Wisconsin Counties and Towns Association thing, and all the face of the, you know, the local government were there, and the question is, well, you know, what's in the ground? And from an election standpoint, all right, is the, you know, it's the institutional memory, right? So like, how could any decision based on these resources impact my voters? Which actually creates a very bipolar argument for these things. And so if you're in Madison or some metropolitan area, then you might not realize all the other side of the coin is being presented from somewhere like north of Highway 8. So voters in Wisconsin, in Madison versus voters in Rhinelander or Ladysmith have very different goals, which comes back to this: what are my values? And then finally, from an environmental protection standpoint, you're also curious about what's in the ground. What you're more concerned about now is what's going to come out of the ground. And maybe it is just leave it in the ground, period. But if it was to come out of the ground, what's coming out of the ground? And if it's mined, how will this impact the environment? And that's a very complicated question, and a very expensive question to even begin to address. And then, if you can concede defeat, if you want to call it defeat, and we're actually now going to mine it, and things aren't going your way, how can any risk be mitigated? How can we actually, right, keep an eye on this thing? And again, I think our students, especially like the ones what's in the ground, we are rediscovering that right now. The new generation of politicians and environmentalists and resource developers and the general public, all right, don't really know the whole story, or it's very fragmented. And so our students are now contributing that. And, you know, environmental students can also play a role in this. We have environmental science and hydrology students that can also play into this equation as well. So, with all this, what do you need to know? I think the way to go forward now is well, we just got to keep learning everything still. It really comes full circle. It hasn't, reflecting on the questions across all the themes, is we still don't fully understand what's in the ground here, because it's just, people are very secretive. So we've been to 5 of these things. We're just going to keep going. We're going to keep digging. We're going to keep finding different ore bodies, whether it be keep begging ORSP for money or find companies to pay for it. And we're just going to keep expanding. And hopefully, eventually, when I am old and gray, and I'll have a knowledge of all these things. Maybe not. And I know that because there's exploration companies that can't find, for example, this black dot. There's no record. They know there's an ore body there. They know the grades, but they don't know where any of the material is or even where they drilled. They just know there's a black dot right there. It's funny, but it's not funny at the same time. And I'm just going to keep making friends. And I'm just going to keep looking for people with samples and companies that are now looking with the change in the legislation to look to invest. And I'm just going to say, hey, we know some stuff. And maybe we can collaborate. And continue doing outreach activities, because what we find and can help across the board here, people feel either better or worse about Wisconsin resources. So again, UW-Eau Claire students are really playing a primary role in rediscovering Wisconsin's ore bodies. And so with that, I'm all done.
Time for some questions.
Given the fact it's mostly geology people in here.
Do you think these old exploration geologists, whatever they are, do you think they have something to share with you? Do you think they really are holding back on some real answers that you'd like to get a hold of?
So I know, like, for example, a lot of the geophysical surveys, that those are the things that where they can actually see through these glacial deposits and stuff like that. Those are closely guarded secrets, because those actually will show conductors, which might be a sulfide ore body. And so a lot of the original maps and things like that are, I don't know, they're holding on to it. I can't say this is universal. Like, you know, for example, I'm collaborating with an individual now as an exploration company, and it's very open and collaborative between us. But there's another individual out there that's not so open and collaborative. My students are laughing because they know exactly who I'm talking about. And why? I don't know why. I guess it's that competitive nature, I guess. You know, they're really just, it's their secrets. It's their thing to find and discover. And I don't know. And that's fine. That's the way they feel, and that's the way they feel.
So did they collect the geophysical data, or were they?
So that's, I mean, I don't know entirely, right? Because it is so, I mean, you would assume that it's company A, and they were a senior geologist at the time, and that company just sort of disintegrated, and they just kind of, yeah. So, you know, I mean, that happens for sure out there in the industry. Some senior person in that company kind of just inherits the old hard copy maps and stuff like that. But, yeah.
So for the Flambeau mine,
Yeah.
why did they decide to not explore the non-enriched portions?
Part of it was because of this looming change in the legislation.
Oh, okay.
You know, so while they were going through this Flambeau process, the Cranon thing was also going, and really Cranon, the size of that operation really caused a lot of that pushback. And so that's when, you know, the mining moratorium was starting to be put in place, and so they actually last second changed their permitting, and they only went after the enriched cap so they can just, so they can close up and get out of town. I mean, also, it was, you know, it was direct shipping ore. They could just basically mine the stuff. They didn't have to process it there, so it was a cleaner mine. They just ship it off directly to smelters with minimal milling. So, you know, it was very profitable to do so. But going deeper would have put a whole bunch of different technical aspects into that process, potentially opening up the need for a mill, which creates tailing ponds and everything else. And so this was definitely the easier, less dangerous or less risky way of approaching this. Yeah.
So does that mine meet the 20-year legislation window?
Yes, in my opinion.
Someone else's opinion?
So there is a history here. So there was a stream that ran through their rail yard, Stream C. And this part of the reclamation project was actually outside the permitting regulation for the company. And so where they were loading the rail cars with the ore, there was additional ore and stuff on the ground, which caused some copper and metal leaching into Stream C, and they detected that. Now, the company was completely within their permitting, all right? And so I guess in that regard, all good. And what happened is when they discovered this, they actually went into this little spot and reclaimed, you know, they went in and fixed the problem. Now Stream C is not a problem, but again, then you look at, has it polluted in 10 years? According to the government, yes. According to, you know, technically speaking, I'm saying now currently yes, but at the time, you know, it kind of reset the clock. So, and you know, it's not easy. You got a monitoring well right down into the heart of the pit, right? And so if you go to the bottom of the thing that tests that, you're going to get anomalous concentrations of things. Now they also have it, you know, filled up with limestone and everything else to help buffer some of that, but everything right now is within permit.
Why weren't they mining all the other ore bodies before the moratorium went into effect?
It was, you know, for example, the Crandon was the big one, right? So this was the 60 million ton one. That one really did come up against the pushback where they were trying to put the facilities and stuff like that. And so as an investor, you have to realize that as a mine, you don't make a dime until you actually send the first ship full of concentrate to a smelter. Everything prior to that is 100% investment. And so you're watching the legislative climate here in Wisconsin as an investor. You're not going to really invest in something that you're not sure can go yet. And so there was kind of this halt in investment, and then it all came raining down after that, right? So that's why it hasn't been mined. I mean, it's still like even back in the 60s and 70s, there's still hurdles you had to jump through to prove that they're not going to ruin the earth. They weren't necessarily as tight as now, but